Let's solve this differential equation, this non-homogeneous differential equation with constant coefficients using the method of undetermined coefficients. The general solution is y equals y sub c plus y sub p, where y sub c is the complementary solution and y sub p is the particular solution. So for the complementary solution, what we do is we'll solve the homogeneous equation whose auxiliary equation is m squared plus 9 equals 0. So our m squared is negative 9, and that gives us m to be the square root of negative 9 is plus and minus 3 times I. So it's an imaginary root. So for imaginary root, the solution is c1 cosine of 3x plus c2 sine of dx. And then for our particular solution, let's look at the right side of the equation. That's r of x equals 5e to the x minus 162x. Now this is actually a particular solution of some homogeneous equation whose auxiliary equation will have roots m prime. Let's call it m prime because we have m already here. For the first term, the root should be 1. That's why we have e to the 1x or e to the x. And we must have two repeating zeros to get 162 times x. It's the same as having c1 e to the 0 plus c2 x e to the 0. So that's why we have x. That's because of the two repeating zeros. But here for y sub p, if we write y sub p, we will not use C1, C2, C3, and C4. Instead, we'll use A, B, C because this is a particular solution. First term for this root 1, that's A times e to the x. So instead of C3, e to the x, we'll just write A times e to the x. And for these two repeating roots, the first one will have B e to the 0 plus C. Now we'll start introducing x e to the 0, or our y sub p is just a e to the x plus b plus cx. Okay, next we are going to substitute y sub p to the original differential equation, but we need to find first the second derivative of this. Y sub p, the first derivative y sub p is a e to the x plus 0 plus the derivative of cx is c. And then y p double prime, or the second derivative, is a times e to the x plus 0. We substitute this one here. We get, for the second derivative, a e to the x plus 9, this one, times y sub p, a e to the x, or this one, plus b plus c times x equals the right side, 5 e to the x minus 162x. A e to the x plus 9 a e to the x is 10 a e to the x. 9 times b is plus 9b. 9 times cx is plus 9cx equals 5 e to the x minus 162x. Okay, next we are going to equate the coefficients of the terms on the left side and the right side of the equation. So we'll start by equating the coefficients for e to the x, that's 10a on the left and 5 on the right, and that gives us a equals 1 half. Then the constant term 9b should be 0 and b equals 0. And then the coefficient of x on the left side is 9c, the right side is negative 162, which gives us c equals negative 18. Now our y sub p, this one, becomes a, which is 1 half, 1 half times e to the x plus b, which is 0, and plus c times x, that's negative 18x. So again, y, or the general solution, is y equals y sub c plus y sub p. Y sub c is c1 cosine of 3x plus c2 sine of 3x plus y sub p 1 half times e to the x minus 18x.